He heads the Polymer Marketing Group at Indian Oil Corporate Office, New Delhi. He has over 28 years of experience in petrochemical industry and has worked with two of the major petrochemical giants in India, Reliance Industries Limited and Indian Oil Corporation Limited. He has worked in different verticals like technical services, application development, sales and marketing, and has also headed the production application and development centers at Indian Oil. He is associated with industry associations like Indian Plastic Institute, Indian Institute of Packaging, Plast India Foundations, etc. in various capacities and with various education institutions like visiting faculty. He is also in the editorial board of Education Committee of Plast India University. His talk on challenges and opportunities in petrochemical industry in India promises to be a treasure trove of insights. Sir, we are honored to have you here.
You are the future industrialists or academicians in this great country, and you will take India to a developed nation. So my thanks to all the professors who are sitting here and to all the students. With me I have two of my colleagues who have come, one from our Product Application Development Center from Panipat. He will share on the polymer manufacturing technologies, applications, etc. And one of my other colleagues, he is on the way, he will talk on sustainability and biopolymers and how circularity is going to be the new norm in the society in the coming days. So my theme of presentation is petrochemicals touching billion lives. I will walk you through how polymers and petrochemicals are really changing our lifestyle and how it has made our life so very easy. See, this is a picture of a operation theatre, and you can see the doctors, the nurse, the attendants, they are all wearing this medical non-woven fabric which is made of polypropylene, be it mask or be it the gowns or the caps. So when a baby is born, his first contact with the doctors is with the gloves, with the aprons, with the mask, or say disposable syringes. Gone are the days when glass syringes were used. Now it is all polypropylene disposable syringe. Then your blood bags. So everything what a baby comes into his first contact when he is born, they are all plastics. So I define that life begins with plastics. And through our entire journey, you will find that without plastics today, nothing is possible. This is a topographic picture of a society, and here you will find that everywhere it is plastics, starting from the water transportation lines, which is made of PVC pipes, then inside the house, the toiletries, the electrical wires, which is having insulation, which is made of polyethylene. Then if you go outside, the cars which you are sitting, they are having about 150 kgs of plastics apart from the tires. Then the battery containers, be it the inverters which is there in the house or the battery containers which is there in your car, they are made of plastics. Then the solar panels today, they are having EVA film. Each and every solar panel is having a EVA film. Then everything what you look around, they are all having something or the other which is made of plastics. This is a photograph of a living room. If you see the photograph very carefully, the next I will show you that if plastics are taken out from this room, your living room or your drawing room, how the room will change. This is how it will look like. This was the earlier picture, and if I take out all the components which are made of plastics, this is how it looks. There are no televisions, there are no floorings, there are no printers, there is no electricity, everything is gone. There are no mobile phones. This is the photograph of the kitchen. And if I take plastics from here, this is how it looks. Similarly, this is your toilet. And this is if there are no plastics there. So you can see everywhere in your daily life, you are using something which is made of plastics from morning till late night when you go to bed. With this, now what are plastics? Plastics are nothing, they are polymers basically, and the basic feedstock is either crude oil or natural gas. They are all coming from the Mother Earth, and about 4% of crude is converted into polymers globally. In the refineries, say oil refining companies like Indian Oil or Reliance, what we do, we import or we take out crude from the crude oil wells, and then we do the refining process, which is a distillation process, and we take out different fractions. One is gasoline, another is diesel, another is LPG, aviation fuel, which is kerosene. So with that, one cut is naphtha, which is around final boiling point of about 105 degrees to 130 degrees. So that cut naphtha is having the basic feedstock like benzene, toluene, xylene, which is coming from the heavy naphtha, and from the light naphtha it is ethylene, propylene, butadiene, which is C2, C3, C4, which are the basic feedstock for polymers. From ethylene you make polyethylene, LDPE, high density polyethylene, monoethylene glycol, polyvinyl chloride. From propylene you make polypropylene, you make propylene oxide, you make acrylic acid, you make acetic acid. And from butadiene you make butadiene rubber, polybutadiene rubber, styrene butadiene rubber, which are all thermoplastic elastomers. So these are the basic feedstock from where you get all the polymers, be it thermoplastic rubber or be it fiber, which is coming from xylene and toluene. From there we make terephthalic acid, PTA, and PTA is then polymerized with ABG, monoethylene glycol, to make polyethylene terephthalic, which is a PET fiber. And natural gas also is another feedstock for making polymers. From natural gas you get ethane, you get propane. They are again put into the gas cracker, and from there you again get ethylene mostly, and you get some part of propylene also, which is again polymerized to make polymers, polyethylene, polypropylene, etc. Polymers are, synthetic polymers are not very old. They are roughly about 100 years. Bakelite was invented, first synthetic polymer, phenol formaldehyde thermoset resin, that was invented in 1907, and the first thermoplastic polymer was PVC, which was invented in 1913. Polyethylene was LDPE, low density polyethylene was discovered during World War II, and many of you will not be aware that the British that time, who were a part of the Allied forces, they had access to low density polyethylene, and they could identify the through radars they could identify the German missiles, and that is how the war was won, because the Germans did not have access to LDP. So that is how it was discovered out of necessity. And then came nylon, which was in 1935, which was again aromatic discovery, was again milestone, and the scientist is in the Hall of Fame in US. I am not remembering his name anyway. And so polypropylene was discovered in 1956 and 1952, and HDP was invented in 1953. So synthetic polymers are not very old, but today they have become very, very important, and they have changed our lifestyle. In India, the discovery of or the manufacturing of polymers started in 1959 with the first plant which came up in Rishra in West Bengal by ICI, Imperial Chemical Industries that time, which was basically from ethanol, and from molasses they used to make ethanol, and from ethanol dehydration technology for making ethylene, and then LDP, low density polyethylene. That was a 20,000 tons capacity plant in 1959. It came in Rishra. But over a period of time, that technology was, became obsolete because of high cost of production. And the first cracker came in India by, it was put up by Union Carbide, which was a 20,000 tons ethylene capacity. That was in Chembur in Mumbai in 1960s. And then came Nosil. They had put up a 60,000 tons naphtha cracker in Bombay for making HDP, PVC, etc. But the first mega investment in petrochemicals in India came from IPCL, Indian Petrochemical Corporation Limited, in 1973 at Baroda, which was a milestone development during those days. Because from a single plant you can see so many different varieties of polymers, synthetic rubber, fiber intermediates, detergent intermediates like LAB, and thermoplastic elastomers. Everything came from one single plant, which was put up by Indian Petrochemical Corporation, which was a public sector owned by Government of India. And that became a revolution in India. And after that, the next big investment came from RIL, which was in 1991 at Hazira with PVC, polyvinyl chloride, and after that polyethylene, that is HDP and linear low density, came in 1994. Then Phenolics came up with PVC, Phenolics Industries, and in last almost from 1970 till 2010, that means in 40 years, or you can say about in 45 years, 10 million tons of plastics consumption happened in India. That is 10 million tons. It touched a figure of 10 million tons per year in 50 years. In 2010, the plastics consumption in India was 10 million tons, but from 2010 till 2020, in next 10 years, that 10 million tons became 20 million tons. So that was the growth rate, and today we are consuming about 22 million tons of plastics in India. And India today, still we are a net importer of polymers, because the demand in India is humongous, and we are growing almost at the same rate as that of GDP, which is about 6 to 7%. And you can see in last 60 years, our ethylene and propylene, which are the two building blocks which I showed earlier, that has grown by almost, ethylene consumption in India has grown by more than 70 times, whereas propylene consumption has grown by more than 100 times. So this has been the growth, and it is estimated that in next 10 years, that is from 2025 till 2035 or 2040, our ethylene consumption will double and propylene will be 3x. Even from such a high figures of 10 million tons and about 8 million tons of ethylene and propylene in current scenario. So why petrochemicals are growing at such a fast pace? That is because you can see that each and every sector, be it medical or be it the smart cities or be it solar, that is new developments, be it digitalization or be it in agriculture, infrastructure, automobiles, appliance, anywhere you talk packaging, you find it is only polymers, and without their presence, that sector will not be able to take off. These are some of the examples and some of the photographs which, if you see, this is a photograph from a departmental store. All the glass bottles, mostly, they are now converted into PET bottles because of its excellent barrier property, that is gas barrier and water vapor transmission, because of its unbreakable nature, excellent gloss. So even drugs, the glass bottles are converted into PET or polypropylene. This kind of Stanley packs were not there in India till about 10 years back. They were either tin containers or they were glass containers, but now these Stanley pouches are there. They are easy to carry. They are very hygienic. The product which is packed inside, you can see the shelf life printed. You can see the FSSI print on it, certifying that it is made from food grade. You can see the composition of the content inside. These are the products which we use in our daily life, from breakfast till lunch, dinner, evening snacks, etc. or the FMCG products which we use. Everywhere the packaging is plastics. Almost the industry estimate is almost 70% of packaging is made of plastics, and rest are paper, aluminium or metals, glass also. Automotives. Today it is a mileage of 20 kilometers per liter is very common for any car. But till early 2000, we were using ambassador cars and Fiat. They were having a mileage of not more than 10 kilometers max per liter. So you can estimate what kind of pollution it was generating. And with the invent of plastics, mainly engineering plastics or polypropylene compounds, the weight of the car has reduced drastically, and today about 150 kgs of plastics are used in a B-type car, and that has drastically reduced the weight. Almost half of the volume of car is made of plastics, but it is weighing only 10% of the total weight of the car. $30,000 components is there in a car, and about 1/3 of them are made of plastics, and they are mostly made of polypropylene and then polyurethane, PVC and polyamides. So it has made the car lighter. It has contributed to less pollution and protection of environment. Next is infrastructure. Infrastructure, be it development of a new city where you require HDP pipe, PVC pipe for water transportation, or for building the roads where you need geotextiles, or for large diameter pipe which is about say 2.5 meter diameter, or for laying cables which is either optical fiber cables where you need this PLB ducts which is made of HDPE. Incidentally, Indian Oil we are supplying to BSNL the HDPE grade which is used for this Digital India. We are supplying to them since 2013. And the entire network which is made in India for digital network that is made of HDPE supplied by Indian Oil to BSNL. So that digitalization process requires pipe. Then Swachh Bharat, you need bio toilets, drinking water supplies. Jal Jeevan Mission will last about 10 years. Huge quantity of P100 and P80 pipe has gone for this Jal Jeevan and Har Ghar Jal Mission schemes. So everywhere, wherever there is a development of infrastructure, development of cities, development of highways, you need plastics. These are some of the actual photographs where you can see that geogrids, geotextiles, geocells, they are used for construction of highways, construction of ports, then river lining for prevention of erosion of soils. These are actual photographs where geosynthetics are laid on the railway track. I have been with some of the projects with RDSO where they have laid geotextiles in tracks in northeast from Guwahati to Nagaon. There was a stretch where Rajdhani had to slow down the speed because of very low subsoil layer. But after laying the geotextiles, the speed of Rajdhani was the same. It was 130 kilometers per hour, and this is how it supports the underlying sub-layer of the soil. And these are some developments which are very much there in developed nations, but in India it is still, I will not say it is nascent, it has picked up, but there is a lot of scope, and today all the national highways which are getting constructed, they are all using geogrids and geosynthetics. Then this solar panels, plastic floaters, which are basically on the ponds or on the rivers. These floaters on which these solar panels are put up, they are made of HDPE, high density polyethylene. So there is a company, French company called CSATPP, who brought this concept in India in somewhere around 2015, and we have worked with them and we have developed this grade and this process by which you can make this kind of floating panels on which the solar panels are put up, and they are, the life of these floaters is guaranteed for 25 years. This is our COVID-19 days, where life had suddenly come to a standstill, and overnight we had to gear ourselves for PPE kits, for disposable syringes, for vaccines, for hospital beds which had to be put up overnight, face shields, then sanitizer bottles, safety goggles. So everything, if you have noticed, everything was made of plastics, be it polypropylene or be it polymethyl methacrylate, PMMA, or be it polyethylene, ATP, low density polyethylene films. Then recall that time everything was closed, all the restaurants, everything was closed, and food delivery increased multiple times. So all the takeaway containers, they were all made of polypropylene, which was use and throw containers, which were used for delivery of food items from the restaurants. So this is how plastics have saved our life, and if it was not there, just imagine if face mask was not there during that time, what would have happened? IV fluid bottles, blood bags, disposable syringes, blood sample vials, sanitizer bottles, small and big containers. Then I am leaving apart the other very highly related with operations like ventilator components, etc., or heart valves, which are again made of polymers. So now you can, I think I've told you a lot about how plastics is a boon and how petrochemicals are changed our way of life and how it has made our life so very simple. To give you a simple example, the mobile phones which we are using, the screen is made of liquid crystalline polymers. And imagine if mobile phones are not discovered, how life would have been. I mean, transferring money in a just click of a button became so very easy with mobile phones, calling anybody across the world. So then the discovery of the satellites, where the connectivity has improved. So these are some of the very novel discoveries which has come out of blue sky research in the field of polymers. But what are the challenges, especially sitting in India, what are the challenges of this industry? First of all of you must know that India is a country where we don't have sufficient quantity of feedstock for our own consumption. That is, annually we process about 250 million tons of crude and about 50 million tons of gas, natural gas. 50% of natural gas, about 25 million tons, is our in-house production, but only 15% of crude oil is our own production from ONGC and Oil India and from Vedanta. But balance 85% of crude oil is imported. So we are heavily dependent on the feedstock for petrochemicals and for our other energy requirements. So that is a very big obstacle and a big challenge for the petrochemical industry, that we have to depend on imported feedstock. So there are kinds of very high price rise because of so many factors. Number two, where you come into picture, that is the academia in India, the institutes, they come into picture, is that in India we don't have our in-house manufacturing technology for any polymers, anything, be it polypropylene, be it nylon, be it polymethyl methacrylate, be it even simple kind of plastics. We don't have our own technology. It is, it is very sorry state of affair. I'm very sorry to say that we have so many good institutes in India. All the IITs, all the brains are there in our country. We are, our students are going for higher studies in other countries in US and all, and they are doing so well there. But in India, we have to depend on companies like ExxonMobil, Shell, Basel, Chevron Phillips, Dow Chemicals, they are the licensors and they are the technology providers. And in the process, what happens? They don't license their new technologies. They license the technologies which has become old, and then they give it to the nations who are dependent on. So all the specialty grades, if you think in plastics, be it metlosin LLDP or be it specialty grades in polypropylene or in engineering plastics like nylon 6,6, they are all imported. We don't have plants in India for making specialty grades because the technology is not available. They give license for technologies which they have discovered 50 years ago. Today they have shifted to a new next generation of technology or catalyst. But we don't get that. We get it after 20 years. So we are always behind the developed nation. So that is one thing which I would put forward in this August gathering of students and professors, that kindly concentrate on blue sky research and develop technologies for polymers or for whatever field you are working in, because India badly needs their own technologies, own catalysts, own additives. We cannot depend on the technologies and the catalysts from other companies. You won't believe that during COVID, when the world had come to a standstill, we had to airlift catalyst from Ferrara in Italy, our licensor Lindner Gassel, for making polymers, because if we did not make, if we had shut down our plant, we could not have supplied raw material for making disposable syringes. Hindustan Syringe, the Discovan brand, they are our biggest customer. We supply almost 1,000 tons of polypropylene for making the disposable syringe. And that time, disposable syringes, then PPE kits. Overnight we had made a grade for making the PPE kits. So if we had shut down our plant, then this support for the COVID, it would have again come to a standstill. So we had to airlift the catalyst from Italy and we had to run the plant. But if we had our own catalyst, if we had our own process, if we had our own technologies, then this kind of crisis days, this thing may again repeat tomorrow. It's not that it may not come. Again some crisis may come up, some war may come up, something may come up where again we are dependent heavily on China, whatever said and done, on bulk drugs, on capacitor films, on many of the basic raw materials in the chemical industry. And in Indian Oil, we are being told by the ministry that we have to develop or put up plants for making this kind of products, which are hugely imported in India. India imports almost $17 billion of chemicals and petrochemicals, which is expected to jump to about $50 billion product by 2040 if we don't plan to put up our own manufacturing units. So polymer and the chemical engineering faculties and the students here, you have a great role to play in the development of our country or discovering this kind of technologies, and that is very, very essential. And the third challenge is this industry is highly capex driven. I mean, putting up a petrochemical plant today is nothing less than about 40 to 45,000 crores. So you have to have very deep pockets for making petrochemicals in India. You have to import the raw material, either crude. If you have your own refinery, then you are somewhat safeguarded in the cost variations. But there are standalone petrochemical plants in India like Haldia Petrochemical who are importing naphtha, and for them it is a big challenge to contain their cost of manufacturing and sustain in this kind of crisis. So high capex is again another challenge for a petrochemical manufacturing unit. But the opportunity is that in India the demand is humongous. I have said that today we are consuming about 22 million tons of plastics annually, and about 1 million ton consumption is adding every year. And the plants which are being lined up today, for example, Indian Oil, we are making about 4 million tons of petrochemicals, and by 2030 that 4 million tons will become 13 million tons. We are coming up in Paradip with a dual feed cracker. Then we are coming up in Panipat with our addition of 10 million tons refinery. So we will put up additional petrochemical polymer plants there. So with that, from 4 million we are going to 13 million, and there are other companies who are also putting up, like GAIL is putting up a propane dehydrogenation PDH manufacturing plant in Usar in Maharashtra. Hindustan HRRL, Hindustan Barmer refinery, they are coming up refinery and petrochemical complex in Barmer in Rajasthan. So these kind of plants, about 1,20,000 crores of investment is happening as I speak now, which will come up in next 5 years. But still there will be a huge demand supply gap, and that is one opportunity that whatever you make, it will have a market, and the growth is enormous. We have feedstock in our country, we have naphtha, but they are scattered among the different refineries. So pooling of naphtha is important, and once you have that, and there are many other streams in the refinery which are today not judiciously used for feedstock for making petrochemicals, so those can be used. And another opportunity is coming up in this China Plus One global shift, that is globally the world wants one more manufacturing country apart from China. So India is becoming a manufacturing hub for many of the products. For example, India imports about 250 crore worth of toys, plastic toys. Mostly it was coming from China, but today almost I would say 75% is in-house, and Chinese toys have almost stopped. So like that, there are opportunities in textiles, there are opportunities in basic chemicals, specialty chemicals. So manufacturing hub, India is becoming a manufacturing hub. And this is one slide where I have made a sort of SWOT analysis. Here, what are I think this focus on R&D and focus on exploring institutes will play a role in, as I said, explained in detail, in developing the technologies and for developing alternate feedstock for petrochemicals. So these are the two roles where industry will have to play a role. And Government of India is developing the ecosystem. They are coming up with PCPIR, that is Petrochemical and Chemical Manufacturing Industrial Region, PCPIR, where there will be anchor company like say Indian Oil or ONGC, and they will provide the basic infrastructure, basic feedstock, and there will be downstream chemical industries who will manufacture different products. So that ecosystem is being put up by Government of India, which is there in different parts. In Singapore, there is a place called Zurang, where this kind of PCBIR is there. In US, it is there in Houston. So India is going to have 4 such PCBIR. One in Paradip, another is in the West Coast, one most likely in Vizag. So this kind of PCBIRs are going to come up shortly. And then pooling of feedstock and joint venture collaboration with the companies, especially in the Middle East, who are having cheap feedstock like gas. They are being worked out by both by government of India. Our PM was there in Saudi Arabia, and you may have read he has announced 2 refineries in collaboration with the companies who are there in the Middle East. So once the refinery comes up today, it has to be backed up by a petrochemical plant also. Standalone refineries does not work today because the GRMs have become very less and they are not viable. So pooling of feedstock and joint venture collaboration with the world majors, this is being done by the industry. The institutes should focus on developing technologies in petrochemicals and for developing alternate feedstock apart from the fossil fuels, which has to be, of course, at par with the polymers which are currently in use. So to summarize, I will say that our consumption today, like this, today we are almost 22.5 to 23 million tons of consumption of plastics in 2024. So this demand is, we are seeing, is doubling every 10 years. So by 2040, our demand will cross, now it looks it will cross almost 35 million tons. And this kind of demand will have to be supported by investments and backed up by cutting edge technology with cheap feedstock, alternate feedstock, and something which has to add value to the society. And polymer is one where it has shown that you cannot imagine life without plastics today. So thank you, and any question I'll be happy to answer.